Hey there, hope you're doing good. Let's continue refactoring Futurecam. We'll start with this easy task, which is to search for all signed ints in the code. Let's look from the bottom up. Yeah, here this is not about int or signed int. Actually, here it should be an unsigned int, don't you think? Because the minutes and seconds can't be negative. Like theoretically, you can argue it can be. If it is 1 minute 45 seconds, you can model it as 2 minutes and seconds is minus 15, but no one does that. So let's make it uint. And also we should make it minutes and seconds. This is not clear, but that's not within the scope of this commit. So we'll just put it to do. It's trivial, but I don't want to lose focus. Because these are uints, this has to be a uint. Okay. Yeah, there is no logical reason why this is an int 32. Why not an int 64? Like you can say we don't need a 64-bit int, but we don't need a 32-bit int either. We are not going to capture 2 billion frames per second. A 16-bit integer like 32,000 frames per second is itself more than what the hardware can support. So let's see what we can do about this. Let's start by working with this. Now you can use, you can use uint. So you can do this, or you can make it uint 16 and so on, but I don't want to. Like if you play the game of how many bits does this need, it's just unnecessary. Like we don't need to optimize every byte. And then changing the data type from one place to another will also be an overkill. So for example, logically you can argue that the width, it can't be an 8-bit integer, it has to be a 16-bit integer, right? But that doesn't work practically. I mean, maybe we'll try making that refactoring, but you can't do that without the compiler. The other annoying thing with Swift is, this is a Swift flaw. An 8-bit integer can't be promoted to a 16-bit integer as far as I know. Let me validate that. Let me just try to quit some apps here. Never mind. We'll make this a uint 32, let's say. I don't think the compiler will like this. Yeah, see, this doesn't make sense, because according to Swift, a uint is either 32 or 64-bit, depending on whether you are using a 32-bit CPU or a 64-bit CPU. But in either case, you should be able to convert this. If this doesn't work either. So yeah, in practice, it's annoying with Swift. So we'll just leave it as uint. Similarly, a uint 32 should be convertible to a signed int 64 implicitly, because it fits. Anyway, we'll try making these changes. If they don't work, we can always do something about it. Are you really going to take a 64-bit number of frames to, so suppose you use just uint, actually uint is again uint64, so it's the same thing. I don't want to look at the controller code right now. Yeah, this can also be uint. Actually, I think the way this code works is you can round it to -1 places. So if you have a value like 79 and you round it to -1 places, it becomes 80. So I think that works. So we leave it as it is. Yeah, the burst count has to be an integer, user defaults. There's no unsigned integer. Yeah, I guess that's fine. We'll look at these diffs. Maybe some of them should not be made. Maybe I'm getting carried away, in which case we'll revert them before committing. You don't need to put the 8 and 3. Oh, this is an object. Converting an object to a uint doesn't make sense. I thought this is integer. No, it's an object. Oh, here we are using integer. I don't even know why we are converting it to uint. Unnecessarily, because we are going to convert it back to int. Yeah. Here you need to convert it to uint because you are returning a uint, not here. So inc works, you are getting it, adding +1 and setting it. These reading things also converted to uint, okay. Okay, let's look at the diffs. I think all the ints have been removed, and this search will also find uint, not uint, sorry, int32, int64, int16, all this will be found. I don't think Swift has a short. Okay, let's look at this. Capture format, width, height, okay. User defaults. These are all counts, how many long exposures the user has taken, how many light trails. So these are logically uints. You cannot take -1 time-lapse videos. And this code, yeah, it's just like a minor cleanup. Abstract video mode is just an override. Light trail mode, just an override. Camera timer, yes. Which leaves only the fast video writer. So frames taken should be straightforward. You're just doing plus equal to. This works, all of them work. We should just look at the CM time initializer or constructor for those of you who are not into Apple. CM time, what are the two arguments? Value times scale. Int 64. Yeah, nothing here. So here it should work, I guess. It says int 64, and earlier it was an int 64, right? Yes. Yeah, we'll just convert it to int 64 to satisfy the initializer. So basically, if you have 3 layers, let me show you this way. If you have 3 layers in your system, A, which is built on top of a lower level B, lower layer B, which is built on top of a lower level C, or we'll call it platform. This is the underlying platform you are building on top of, like iOS here. B is things like extensions and helper classes and so on, which are part of your code. That's why it's not platform. And A is the core logic. Now B can have the same interface as the platform and just expose it up. And if someone asks B, why do you provide this interface? B will answer, I don't know, the guy below me provides the same thing, so I'm passing it up. Like here. If you were to ask the fast video writer, why is the number of frames taken in int 64? Why is it not int 32? Why not unsigned it? It will say, I don't know, the underlying iOS API offers that, so I'm just passing it upward. That is one approach. The other approach is for B to provide for B to provide what makes sense logically, or for B to provide what A needs. That is the change I've made here. Logically, this is a uint. If there is some adaptation needed between B and the platform, B will take care of it. So B as an abstraction is growing a little bigger in scope to make A's life easier, which makes sense because B exists only to make A's life easier. So here we have taken care of frames taken. We should look at frame rate. Okay, you are assigning it to self. Then what are you doing with it? Oh, this is the time scale. Okay, great. Yeah, if we get a compile error, we can deal with that. Sorry, I'll just turn off my alarm. So if we get a compile error, we'll deal with it, but let's banish the signed dates, because all of this frame rate, you can't take minus 24 frames per second, and if you ask how many frames were captured already, it will never be minus 1000. A format, the camera has different formats like 4K and 1080p and so on, but it will never have a negative number of pixels either for width or for height. The counts of time lapses taken and all of those can't be negative. Yes. Use unsigned int for values that logically can't be negative. And we are done. I'll see you in the next video.